Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is logarithm. What we are going to learn today is relationship between logarithmic and exponential functions. How they are related is what we are going to learn today. So let's begin. After completing the very lesson today, my dear student, you'll be able to convert exponential function into a logarithmic function. Similarly, also be able to convert the logarithmic function into an exponential function. This is what I hope you'll be able to do after completing the very lesson today. So as usual, my dear student, in your math segment, that is math is fun. Today, I'm happy to give you another interesting number. This number is 5040. This number is so special, so interesting. In fact, I'll share with you what is interesting about this number after completing my lesson today, so don't go away. To begin the lesson, my dear student, let us just consider a typical example of an exponential function y equals to a raised to the power of x. This is a typical exponential function. So what do we now do? We want to relate this exponential function with logarithmic function. So what we now do, we now take, that is applying log to base a to both sides of this very equation. So you now have log to base a of y equals to log to base a of a raised to the power of x. This is what you now have after taking log or applying log to base a to both sides of this very equation. We continue. One of the properties that we learn, properties of logarithm, if you have the index number, that is logarithm of an index number, the power of that index number will now become a multiplicative factor. So this x will now come and multiply here. So you now have log to base a of y equals to x, log to base a of a. And another property of logarithm says if the number and the base are equal, just take it as one. So this log to base a of a is nothing but 1 times this x. So my right hand side is nothing but I have x only, that is x times 1, which is x. So if you have y equals to a raised to the power of x, and that y equals to a raised to the power of x, now converted to logarithmic equation, you now have log to base a of y equals to x. So just look at the variables there, y, a, and this x, and look at how they appear in this logarithmic equation. There will now enable you to now write the relationship. Hence, if y is equals to a raised to the power of x, that is, you have your typical exponential function. That typical exponential function, to change it to logarithmic equation, just you now write this, you now have log to base a of y will now be equals to x. If I go back to this exponential function, y is what we want to express in index form using a as the base and the power x. But here in the logarithmic function, we want to find, we would like to have a logarithm of y. So it's the same number you express in index, now is logarithm of that number to the base that you have used in index. And this will now be equals to, that is, the logarithm will now be equals to that very power. Similarly, if you have log to base a of y equals to x, you can now write y equals to a raised to the power of x. We try to take examples how we can now convert exponential to logarithmic and logarithmic into exponential function. Let's just move and take examples. Example number 1, we asked to change the following exponential functions into logarithmic function. Number 1, it says 8 equals to 2 raised to the power of 3. Number 2, 100 equals to 10 raised to the power of 2. Number 3, t equals to 5 raised to the power of r. Solution to this very problem. What I would like to write now is just the relationship between exponential and logarithmic. If you have y equals to a raised to the power of x, remember we now said to write the equivalent logarithmic function of this, you now have log to base a of y equals to x. So if you now look at this and relate it with all that we have here and want to change it into this logarithmic equation, we'll be able to do it successfully. So let me start with the very first one. That is 8 equals to 2 raised to the power of 3. 8 will now be your y. This to 2 will now be your a. And this power 3 will now be your x. So if you now have 8 equals to 2 raised to the power of 3, you want to write it into logarithmic, you now have log to base the 2 of this number 8 is now equals to this power 3. Let me just write it. So you have log to base the 2 of 8 will now be equals to 3. And that equation what is now done. You now move to equation 2 where we have 100 equals to 10 raised to the power of 2. 100 equals to 10 raised to the power of 2. So to write it is equivalent to logarithm. You now have log to base 10 of this number 100 is now equals to this power 2. Let me write it log to base 10 of 100 equals to 2. So if I move to number 3, you have t equals to 5 raised to r. So if I want to write it into logarithmic equivalent, I will now have log to base 5 of this number t equals to this power r. Let me write it. So you have log to base 5 of t equals to r. This is how we now changed exponential into logarithmic. Let me just move to the next example where you learn how to change logarithmic back to exponential. So example number 2 is says express the following logarithmic function into exponential function. Number 1, you have log to base 5 of 25 equals to 2. Number 2, log to base 1 over 4 of 1 over 60 equals to 2. Number 3, log to base r of 1 equals to 0. Solution to this very problem, starting with the very first one, but let me just also write below or the relationship. It says if you have log to base a of y equals to x, to write this back to exponential function, your y is the number that you express in index form, and you now use this base a, and that a will now have power x. So this will now have y equals to a, the base, raised to the power of this result, x. So if I start with the very first one, log to base 5 of 25 equals to 2. If I change or write the equivalent in exponential form, I'm now going to have 25 equals to this base raised to this power. So I'm going to have 5 raised to the power of 2 equals to 25. So let me just move to the next one. That is log to base 1 over 4 of 1 over 60 equals to 2. So if I should now write it, I'm now going to have this fraction 1 over 16 to be equals to this base 1 over 4 raised to this very power. So I'm going to have 1 over 4, that is my base, that is my index raised to the power of 1 over 2. This result will now be equals to 1 over 16. So if I move to the last one, log to base r of 1 equals to 0. So I'm going to have r raised to power 0 equals to this very one. So r power 0 equals to 1. This is how we now change logarithmic into exponential function. This is the end of this very lesson, my dear student. I hope you find it resourceable. And let me just move quickly to the last segment versus fun and share with you what is interesting about the number 5040. The number 5040 says is the highly composite number, that is numbers with many factors. In fact, there is no number smaller than this 5040 that has this number of factors, that is this number of divisors. This very number has about 60 divisors, that is about 60 factors, and no any other number smaller than this that is having this as much as 60 factors or as much as 60 divisors. So 540 is highly composite. If you like, you can try to see what are those factors of 5040. I believe if you counted them, it will give you about this number 60 if you did it correctly. Thank you for your attention. We see more of these things in mathematics in our subsequent lessons.